Hey everyone, let's take a look at centroids again. We've already talked a little bit about the centroids of an area as far as looking at the x position of that centroid. And so what we said is we'll take an area here and we're going to break it down into little rectangles, and the x position of that centroid is some value x of I. And we know that the centroid of an area then x bar is equal to the integral of x times dA. But dA was equal to some height, right? So this is going to be f of x here, that's f of x of I. So it's going to be x times f of x of I times dx, where dx is the thickness of this rectangle, right? So that's how we find the x bar. But what about if we want to do the y bar? Well, I can kind of get similar sort of situation. I could break it down over here into a little rectangle over here, and this might be some y sub I, and so y bar would equal the integral of y dA. But y sub I is the position of that one. Then I got to add all these together. And so I'm going to do this very similarly. I'm going to have y. And then this is going to be right the right-hand side of that. So we might consider that to be the x position. So what I have to do is I'd have to do the inverse, and then I'd evaluate that at y sub I. So the inverse of this function. Remember, inverse function is like if I have y equals x squared, and that's f of x, then the inverse of that, we'll make that a function of y, that's going to be the square root of x. Okay, we're not going to play around with this too much, and I'll show you why in a second. So this would be times dy. So you could do this integral, wow, that's going to be a real pain. I don't want to do that. And so in order to find the y bar, we'll go back to the purple rectangle here. The y value here is f of x. Okay, if I'm looking at this point right here, that's the point x sub I, f of x sub I over 2. Because it's a uniform rectangle, then the center of mass, or the centroid of that rectangle, is going to be right in the middle, right? Because it's a nice uniform rectangle. It's going to be in the center. And so it's going to be f of x of I, which is the height of the rectangle, divided by 2. And so that's the y centroid. And so this is the hard way, but we can do it this way. Y bar is equal to the integral of y, which is f of x of I. Right? That's the y value. And then dA, the area, is just f of x of I. And actually, I'm going to come back on this in a second. F of x of I dx, right? This right here is dA. But this is the y position of the centroid, so I need to divide that by 2, because that's right there, right? And so I can do this a lot more easily with x integration, right? I don't have to worry about the inverse functions. I just do an x integration, and I'm going to get the integral of f of x of I squared over 2 dx. And that's how I'll find the y position of the centroid for an arbitrary shape. And so I would just integrate across this, and I would get the y position for the centroid. Okay, so that's the integration process for centroids. Right? That's the integration process for centroids when I'm looking at an area. All right, we can do a similar situation for lines, and we'll do that in the next video. We'll look at that as well. All right, if you have any questions, leave them in the comments below. Thank you.